Hi everybody, this is Mrs. Snook with section 7.4, Matrices and Systems of Equations. And our objectives today is we're going to write matrices and identify their dimensions. We're going to perform elementary row operations on the matrices. And we're going to use matrices and Gaussian elimination to solve systems. So first off, let's talk about what a matrix is. So if you look on the screen, all four of these are considered matrices. And what it is you have those brackets on each side and then the numbers inside. And the numbers correspond to the coefficients of your variables. And then your dimension of a matrix is the number of rows and then a cross, so rows, and then cross, and then columns. So this matrix for A, which just has the number 2, that's 1 row by 1 column, so it's a 1 by 1. Next one, I have 1 row and 4 columns. That's a 1 by 4. C, I have 2 rows and 2 columns, so 2 by 2, and this would also be called a square matrix because you have the same number of rows as columns. D, I have 3 rows by 2 columns, and then E, we have 3 rows and 1 column. That's how you're going to do the dimension of a matrix. The next thing we're going to do is we're going to write an augmented matrix. Because as I mentioned earlier, the coefficients of your variables will go into the matrix. So the first thing I'm going to do is I'm going to write these, and I'm going to leave spaces for any place where a variable is missing. So when I rewrite my system, I'm going to get this, x plus 3y. I don't have a z, so I'm going to leave a space. And instead of putting equals, actually I'll do equals because I'm not in the matrix yet, equals 9. And then the second row, I don't have an x, so I'm going to leave a space there, and I have negative y plus 4z equals negative 2. And then my last row, I have an x. I do not have a y, so I'm leaving a space, and then I have negative 5z, and that equals 0. All right, so now when I go to make this a matrix, what I'm going to do is I'm going to put in my bracket, and each row, so I have row 1, row 2, row 3, each row gets a row in the matrix, and I'm just going to copy over the coefficients. So for my first row, the coefficient in front of x is an invisible 1. I then have 3 in front of y. I don't have a z, so I'm going to put in a 0. And then my second row, gee, I lost my z, plus 4z. My second row, I have a 0 for x, negative 1 for y, and a 4 in front of z. And then my last row, I have a 1 in front of x. There is no y, so I put a 0 in there. And then for the z, I put a negative 5. Then I'm going to put in a dashed line like this. And this says that on the other side of the dashed line is where you put the equals. So since my first row was x plus 3y equals 9, I'm going to put a 9 over here. Second row, I had negative y plus 4z equals negative 2, so I put a negative 2 there. And then x minus 5z equals 0, so I put a 0 in there. And this is what your augmented matrix looks like. So the coefficients in front of your variables, and then put in your dashed line, and then put what they equal. All right, so just like in systems in section 7.3, we could do elementary row operations. We can do elementary row operations on a matrix. So I'm going to show you what that looks like. So the first one says interchange the first and second rows of the original matrix. So this is our original right here. And then when I interchange my first and second rows, I'm just going to swap them. They're going to trade places. So here's what my new matrix would look like. So this was row 1, row 2, and row 3. I'm going to put row 2 up in row 1 spot. So -1, 2, 0, 3. And then I'm going to put row 1 in row 2 spot. So 0, 1, 3, 4. And I didn't move row 3 at all. So 2, -3, 4, and 1. So we are allowed to swap our rows. Just like in section 7.3, I said we could trade equations positions. We can do the same thing in a matrix. Now we're going to multiply the first row of the original matrix by 1/2. So that means that I'm going to take everything in row 1 and multiply it by 1/2. So then this new matrix is going to be 0 times 1/2 is 0. 1 times 1/2 is 1/2. 3 times 1/2 is 3/2. 4 times 1/2, that's 2. And then we didn't make any changes. So -1, 2, 0, 3, and then 2, -3, 4, 1. So that's our new matrix. And these are called row equivalent. So as long as I'm performing valid row operations, my new matrix is considered to be equivalent to the old one. Here's another one. This one is like what we've been doing. We're going to add -2 times the first row of the original matrix to the third row. And as you recall, we would just say, okay, -2 row 2 plus row 3. That's what we're doing. So let's go ahead and do that. And I'm going to put that in row 3. It says to the third row. So this is going to be row 3. Is going to be -2 row 2 plus a row 3. So I'm going to make my matrix. Row 1 didn't change. So this is 0, 1, 3, 4. Row 2 didn't change. This is -1, 2, 0, 3. Now for row 3, I need to do -2 row 2 plus row 3. I think it's easier to actually write it out. So -2 row 2 is going to be 2, -4, 0, -6. And then row 3 is 2, -3, 4, and 1. And I'm just going to add those together. So I get a 4, -7, 4, -5. So my answer goes here, 4, -7, 4, -5. And so that's our equivalent matrix. And then one thing I want you to do is, and the book shows you this, they write the row operation next to the row that changed. So I changed the last row, so I would write it here. Row 3 equals -2 row 2 plus row 3, and somehow I erased. Okay, so write your row operation and then write in the new matrix. All right, the next idea is row echelon form. And this form is useful for solving our systems. And so what we're going to do is when something is in row echelon form, it'll look like this. You'll have a 1 in the first spot, and you're going to have zeros underneath it. And then you can have anything you want over here. And then the second spot of the second row has a 1. And then anything over here. Underneath it is a 0. And then the third row, third spot has a 1 there, then anything over there. So what we're looking for is 1s here, and then everything to the left and below is 0s. So that little triangle of shaded stuff to the left, that's what tells us that we're in row echelon form. So this is row echelon. Now the other kind is reduced row echelon form. And what happens for that one, and this is the best for solving our systems, is first row, first column, you have a 1, and then the others are 0. Second row, second column, you have a 1, and the others are 0. Third row, third column, you have a 1, and the others are 0. And then over here, I can have any numbers I want. And what's happening there is once you get your matrix in this form, you can then say x equals whatever that number is over there, y equals whatever that number is, and z equals whatever that number is. So that's really nice for solving equations. So here we go. I've put down for us 6 matrices, and we're just going to figure out who's in row echelon form and who's in reduced row echelon form. So take a look at A. Notice we have just the zeros going there, and sorry, 1's going across, and then all these zeros there. So that's row echelon. And then if I look at B, I have a 1 here, but look at, I don't have a 1 there. So I'm not in row echelon form. If I was to swap some rows around, I could get there, but I'm not there now. And now look at C. I have a 1. This one is a 0. It should be a 1. Okay? So that one is not our row echelon form. Your book says that it is, but I would disagree with the book, I guess because maybe you have all these zeros here, and so there isn't any other equation with a y. So book says row echelon. And then D, here's our 1s going down the diagonal. We have all zeros underneath, so this is row echelon. It's also, check this out, it's a reduced row echelon. And the reason is all these others are zeros. So I have my diagonal of just 1s right here. And then over here, I have those 3 numbers. So if I was solving this system, I would say x equals -1, y equals 2, and z equals 3. Take a look at E. Now E, I have the 1, and I have a 1 here, and I do have these zeros and this 0, but what's messing it up is that 2 right there. So that one is not in row echelon form. And then look at F. I have a whole column of zeros, so I can just kind of ignore that. And check this out. I have a 1, I have a 1, and below those 1s are zeros. I have a 0 above, and then I just have this 5 and 3. So that is a reduced row echelon form. Okay. All right. So now we're going to do some Gaussian elimination with back substitution. But what we're going to do is we're going to do this with matrices. Okay. So we're not going to write out all the equations like we did before. We're just going to go into matrix form. So I'm going to start in augmented matrix form. I have a 0 for my x. I have a 1, and a -2. And here goes in my dashed line. I have a -3. And then I have second row. I have a coefficient of 1 for the x, 2 for the y, -1 for the z, 0 for the w, and then it equals 2. Third row, 2 for the x, and then 4 for the y, 1 for the z, -3 for the w, and that's a -2. And then coefficient of 1 for the x, -4 for the y, -7 for the z, -1 for the w, and -19. That's the first thing you're going to do is write your augmented matrix. Now I'm looking at my matrix, and I need to have a 1 in that top first row, first column. I need a 1 there. So what I'm going to do is I'm going to reverse row 1 and row 2. So here's going to be my new matrix. And I'm reversing row 1 and row 2. So I'm going to say row 2, row 1, and I was trading those places. So when I'm done there is I've indicated my elementary row operation is going to be trade places. So now I'm going to put row 2 where row 1 was. So I have a 1, 2, -1, 0, 2. And then row 1 is going to be 0, 1, 1, -2, 2. I didn't make any changes to row 3. So 2, 4, 1, -3, -2. And I didn't make any changes to row 4. So 1, -4, -7, -1, -19, and that was a -3 that disappeared. Okay, now the next thing I want to do is I'm checking my rows. Row 1 is fine. So this is good. Row 2 is fine because I have a 0 and a 1. So now I'm going to work on row 3. And I want a 0 and a 0 where I have a 2 and a 4. So that 2 and that 4, I want a 0 and a 0. So I'm going to do some elementary row operations there. And what I'm going to do is my new row 3 is going to be -2 row 1 plus row 3. So I'm going to come over here. I'm going to write my new matrix. So by the way, in case you're wondering, I'm kind of flowing in this direction. And I'm going to write down the row operations I'm doing. So my row 3 is going to be -2 row 1 plus row 3. So -2 row 1 plus row 3. At the same time, I'm going to do negative row 1 plus row 4. And the reason I do that is I can then remove that 1 here. So I am going to let you combine elementary row operations because I think you've done enough of these that you should be pretty comfortable. All right, so no change for my row 1 and row 2. So 1, 2, -1, 0, 2, 0, 1, 1, -2, 2. All right, so -2 row 1 plus row 3. I'm just going to do this over here. So -2 row 1 is -2, -4, 2, 0, -4. And then row 3 is 2, 4, 1, -3, -2. And when I add them together, look at what happens. I get a 0, 0, 3, -3, -6. So 0, 0, 3, -3, -6. Okay? And then I'm going to do negative row 1 plus row 4. So negative row 1 is going to be this, -1, -2, 1, 0, 2. And then row 4 is 1, -4, -7, -1, -19. Add those together, I get a 0 there. I get a -6, -6, -1, -17. Okay. So take a look at what I've got now. Row 1 is fine. Row 2 is fine. Row 3, we're getting close. I have a 3 right there. But what if I just multiplied everything in that row by 1/3? That would take care of that, right? So I'm going to do that next. I'm going to take these out of my way so I can work. Always need to make myself room to work. So I'm going to come down here, start my next matrix. And I said I wanted to multiply row 3 by 1/3 because that's going to divide out that 3. So I'm going to say 1/3 row 3. So row 1 and 2 don't change. So 1, 2, -1, 0, 2, 0, 1, 1, -2, 2. Okay, let's multiply row 3 by 1/3. I can do that in my head, so I won't write it down. 0, 0, 1, -1, -2. And then for row 4, I have a -6, -6, 1. Oh, I think I have a mistake here. This should be -21. Because -2 plus -19 is -21. So let's fix that. And now what I'm going to do there is I'm going to go ahead and I'm going to add 6 row 2 plus row 4. So let's see what happens there. I want to fix this bracket. So if I do 6 row 2 and then I add it to row 4, I'm going to cancel out that 6. So I'm going to do 6 row 2 plus row 4 to cancel out that 6. And I'm going to go ahead and write it out. So 6 row 2 would be 0, 6, 6, -12, 12. And row 4 I have 0, -6, -6, -1, -21. And when I add them, I get 0, 0, 0, -13, and -9. So 0, 0, 0, -13, -9. And just to kind of remember that these are augmented. I'll put these dashed lines in. That just helps me remember. Okay. So now all I have to do is take that last row and I need to multiply it by 1/13. Oh, sorry, I made a mistake again. This is -39. Okay. So then when I multiply that by 1/13, see what I get? So 1/13, row 4. I'm going to get 1, 2, -1, 0, 2. Put in my little dash line. 0, 1, 1, -2, 2. 0, 0, 1, -1, -2. And then 0, 0, 0. And is that a negative? Yeah, I want to do this by a negative here. And I get 1 and 3. So guess what? I can now backwards substitute. This fourth column was for W, just remember. So this was X, this was Y, this was Z, and that was W. So I now know W equals 3, because the coefficient in front is a 1, so that's W equals 3. Backwards substitute in here, and I get Z minus W equals -2. So Z minus 3 equals -2. Z equals 1. Backwards substitute again into here. Y plus Z minus 2W equals 2. So Y plus 1 minus 2 times 6 equals 2. So minus 12. And I have a mistake here. This is -3. Okay, so when I do this, that equals -3. All right. And then W I had was 3. I don't know why I put 6 there. So always check your details. So I get Y is going to equal 2. And then backwards substitute again. Now we're in our top row where I have x plus 2y minus z equals 2. And I'm going to plug in y and z. So x plus 2 times 2 minus 1 equals 2. Minus 1 is 3. So x equals -1. So then our answer is x is -1, y is 2, z is 1, and w is 3. All right, our last example is going to be to use the matrices to do a Gauss-Jordan elimination. And so what that means is we're going to get our matrix into the reduced row echelon form. And when you do that, you can just write the answers down. So you have to go to reduced row echelon form. And for some reason, I cannot write. All right, so reduced row echelon form. First thing we're going to do is write down our matrix. So I have 1, -2, 3, and here's my dashed line for 9. Then I have -1, 3, 1, -2, 2, -5, 5, 17. Okay? And remember, what I want to have is along this diagonal, I want 1, 0, and 1, 1, and 1. So I want 1, 1, and 1. And all the other spots to the left of my dashed line, all those others need to go to 0. And I'm allowed to have any numbers I want on the right of the dashed line. So these ones in green, they may change, but I'm okay with having any numbers there. So when I'm finished, I'm going to be in that form. So the first thing I'm going to do is I'm going to do 2 row 2 plus row 1. So 2 row 2 plus row 1. That's going to happen here. So here's my new matrix. And when I do that, I get 1, 0, 11, 23. So far, this is good, this is good. And I'm also going to, let's go ahead and just, let's just do this one first. And then I have, okay, so next thing I'm going to do is, because I have row 1 and row 2 both have a -1 in front, I'm just going to make a row 2, which is going to be just row 1 plus row 2. So I have 1, -2, 3, and 9. And I'm going to add those two rows together. I get a 0, a -1, a 1, so that's going to be a 4, and a 7. And then for row 3, I'm going to do a row 3 minus 2 row 1. So the first thing I'm doing is I'm working on getting my 1s in the right place. So row 3 minus 2 row 1, let's do that. So row 3 is 2, -5, 5, 17, minus 2 row 1, minus 2, plus 4, minus 6, minus 18. Those go away. I get a -1, -1, -1. So I have a 0, -1, -1, -1. All right, so take a look at this. I have a 1, 0, 0. Over here, I need that to be a 1. So what I can do is I can multiply that row by -1. And then I can use that to make another change in row 2. All right, so now I'm going to take my original, not my original, but my most recent one. I'm going to take that matrix. And what I want to do is I want this -1 that I highlighted in green, I want to make that a +1. So I'm going to do row 2 is negative row 2. So I have 1, -2, 3, 9. I have 0, 1, -4, -7. And then I'm not going to change row 3, so I got 0. Actually, let's go ahead and let's make row 3 a negative as well. So row 3 is a negative row 3. So I get a 0, 1, 1, 1. All right. So this is good. This is good. I have a 1 in the second spot of row 3. I want to make that go away. So what I'm going to do there, come over here. And I have 1, -2, 3, 9, 0, 1, -4, -7. And I have and then what I want to do here is I'm going to take row 3, and I think I'll subtract row 2. So row 3 minus row 2. So I get a 0, 0. 1 minus a -4 is 3. 1 minus a -7 is 6. Okay? So now check this out. I'm getting super close. One thing I see right away that I can do is I can divide row 3 by 3. And this is what I'm going to get. And then what I want to do here is I want to take row 2 and I'm going to add that to 4 times the row 3. So row 2 plus 4 row 3. And I'm using this new row 3, the 0, 1, 1, sorry, 0, 0, 1, 2. So when I add them, I get a 0 and I get a 1. And then this one is 4. I get my 0 there. And then I get a 1 there. And then on top I have 1, -2, 3, and 9. All right, let's take care of that -2. So I'm going to take row 1 and I'm going to add to row 2. So row 2 is going to stay as it is, 0, 1, 0, 1. Row 3 is 0, 0, 1, 2. And then in row 1, I'm going to get a 1. And then I add to row 2, so I get a 0 there. And I get a 3. And then I get an 11. And that's a 1. So now the last thing I'm going to do is I'm going to, and this will be my last step, I think. I'm going to make row 1. And I'm going to subtract from that 3 row 3, because that takes care of this 3 that I have here. So it's 0, 1, 0, 1, 0, 0, 1, 2. And I get, so that's a 1, that's a 0. 3 minus 3 is 0. And then 11 minus 6 is 5. All right, so now I'm all set. Remember, this column was x, this was y, this was z. So from here, x equals 5, y equals 1, z equals 2. So my solution is 5, 1, 2. Thank you for watching, everybody, and have a great day.